Meroka, short for Mehr Rohr Kanone, meaning multiple-barreled cannon in German, was a Spanish close-in weapon system with German roots mounted on a range of Spanish naval vessels. What always draws attention to this system is its distinctive and rather intimidating design, as it's essentially a giant shotgun made up to 12 20mm cannons. The Meroka fired in salvos, creating a dense wall of fire meant to shred any incoming threats. While many military enthusiasts might recognize the Meroka from photos or naval discussions, that's only scratching the surface. The full story of this weapon is much deeper, filled with spin-off projects, experimental designs, and some bold engineering decisions that never made it past the prototype stage. And that's where today's video comes in. Staying true to the tank-focused theme of our channel, we're diving into one of the most obscure and frankly fascinating offshoots of the Meroka story, the BMR-620 project, or in simpler terms, how to mount a giant naval shotgun on a wheeled armored vehicle. To understand the origins of the BMR-620, it's essential to first explore the history of the Meroka system. Following the end of World War II, numerous scientists, engineers, and researchers affiliated with the Third Reich sought refuge in other countries to escape international justice. A significant number of them ended up in Spain, which at the time was under the dictatorship of Francisco Franco, a known sympathizer of Adolf Hitler's ideology. Franco's regime sought to make the best of the situation and offered protection to these individuals, shielding them from prosecution and allowing them to settle and thrive in Spain. Some of them established businesses, while others were integrated into Spain's military and defense sectors. As a result, many Spanish military projects developed during and after this period bore traces of German influence, either through design philosophy, technological inspiration, or direct involvement of these exiled professionals. The Meroka system was born from an idea originally conceived by one of these German technicians, Anton Koch. During World War II, Koch had worked on an anti-aircraft weapon concept in Nazi Germany that essentially functioned like a pellet shot or clustered fire system. While the concept did not gain traction in Germany, his post-war emigration marked a turning point. Once in Spain, Koch began working for the state-owned arms manufacturer Ketme, short for Centro de Estudios Técnicos de Materiales Especiales, meaning Center for Technical Studies of Special Materials. There, he revived his old concept, and the company received it positively. As a result, the development of a prototype began. This is also why, despite being a Spanish-made system, the weapon retains a rather German-sounding name, Meroka, named directly by its inventor. The project officially began in 1954, envisioned as a ballistic anti-aircraft weapon. It was initially offered to the Spanish Air Force as an air-to-air system intended for installation on their various aircraft. However, the Air Force rejected the proposal, which didn't cancel the Meroka project outright, but it did slow its development. With the appearance of the American Vulcan system, Ketme sent a letter to the Spanish military highlighting Meroka's advantages over the Vulcan. They pitched it alongside the Super Long Projectile Project, an independent program focused on developing extra-long 20mm and 40mm ammunition that weighed the same as standard rounds. This was achieved by using special blends of aluminum powder, wax, and lightweight metals, allowing for explosive charges of up to 30% additional power in some cases. Thanks to this innovation, Ketme secured additional funding from the military, and by 1959, the first Meroka prototype was completed. The design also attracted interest from other countries, particularly East Germany. Through the company IKW, East Germany requested the development of two prototypes. The Meroka 12.202, featuring 12 20mm cannons, and the Meroka 8.303, armed with 8 30mm cannons. However, the project stalled when IKW lost interest, although testing continued in cooperation with the West German government. Experiments included proposals by the West German government for a 35mm Meroka variant intended for installation on a tank chassis. Meanwhile, Heckler & Koch GmbH asked Ketme to develop a prototype called the Meroka Multisalva, equipped with 12 7.62mm barrels. Hispano Suiza also showed interest, inquiring about a 12.7mm Meroka version for helicopter applications. Additionally, Ketme explored the concept of a Super Meroka and on their own initiative even began preliminary studies for a 35mm Meroka designed for combat vehicles. However, most of these projects were doomed to development hell and were left incomplete mainly due to a lack of funding. Without sufficient financial support, Ketme was forced to suspend many of these developments in order to cut costs and stay afloat. By 1970, the Spanish military began considering the introduction of the Meroka system across the Army, Navy, and Air Force. Once again, the Air Force declined the idea, but both the Navy and the Army showed interest this time round. The Navy in particular was growing increasingly concerned about the threat posed by new wave-skimming missiles, especially after the Israeli destroyer INS Eilat was sunk by a Soviet SS-N2 Styx missile in October of 1967. In 1975, the Navy held a competition to select a new close-in weapon system, and the Meroka emerged as its winner. It was deployed under its Meroka naval variant across several Navy vessels, becoming by far the most famous version of the weapon and the only one to officially enter service. The Army, meanwhile, had similar concerns. They were also looking for a new ballistic anti-aircraft weapon, and Ketme developed a towed version called the Meroka ATR, short for Meroka al Fuste Terrestre Remolcado, meaning in Spanish, ground-towed Meroka gun mount. It even participated in a military parade in 1984, but it never entered active service. Sometime around 1970, the Spanish Army launched the development of a new armored vehicle, the BMR, short for Blindado Medio de Ruedas, meaning medium-wheeled armored vehicle in Spanish. The BMR is a 6x6 wheeled vehicle that arose for the need for a mobile and versatile transport system. Today it remains in service not only with the Spanish military, but also with several other countries, including Egypt and Peru. During the BMR's development phase, the Army envisioned several variants of the vehicle, including a ballistic anti-aircraft version. This presented Ketme with a new opportunity. In an effort to secure additional contracts, Ketme adapted the Meroka into a turret system suitable for armored vehicles, creating the Meroka Autopropulsado variant, meaning in English, self-propelled Meroka. The self-propelled Meroka was officially presented to the Army for mounting on a BMR platform, and the project received approval. In 1980, the Army authorized the construction of several BMR prototypes, including one specifically equipped with Ketme's self-propelled Meroka turret. This combined platform became known as the BMR-620. To test the integration of the Meroka turret onto a mobile vehicle, an initial trial was conducted using a repurposed AML-60 Panad from the Spanish Army. This vehicle served as a mobile testbed for the Meroka module. Ketme's concept for the BMR-620 involved mounting the Meroka turret onto the BMR-600 PP/T.1, one of the early BMR configurations envisioned during the vehicle's development. This version was designed as a support vehicle and featured distinct differences from the final production models. It was amphibious, had thicker armor, and came armed with a 20mm Gia M693 autocannon and a 7.62mm AAT NF1 machine gun, both housed in an enclosed T20/13 Type C Tucson 14 turret. The plan was simple: remove the original turret and replace it with a Meroka system, effectively converting the BMR-600 PP/T.1 support platform into the BMR-620 ballistic anti-aircraft vehicle. Now, if we dive into the technical details, the BMR-620 would have been a 6x6 ballistic anti-aircraft vehicle weighing approximately 13 tons. But what made it truly stand out was its armament. The final configuration of the Meroka turret, which featured 12 Oerlikon 20x120mm cannons. That alone placed it among the most unique vehicles ever designed, with a frankly absurd number of barrels for a single moving platform. But even more remarkable was its firing system. Unlike most ballistic anti-aircraft systems of the time, which focused fire on a single point, the BMR-620 was designed to saturate an area. In essence, it functioned like a massive shotgun. The 12 cannons fired in salvos of 3 barrels at a time, with each salvo lasting just 0.8 of a second, creating literal clouds of bullets, similar to the spread of shotgun pellets if they were the size of your thumb. The Meroka system also featured a pneumatic reloading system, meaning it didn't rely on the explosive force of the cartridge to cycle the weapon. If a round was defective, compressed air would push it forward and avoid jams, a major reliability advantage. Another standout feature was that each cannon had a rate of fire of just 120 rounds per minute, far below their theoretical maximum of 1,200 rounds per minute. This reduced mechanical stress greatly, allowing the Meroka to fire continuously for as long as ammo was available without overheating or damaging the barrels. When the self-propelled Meroka was about to be installed onto the BMR-600 PP/T.1 chassis, a study apparently revealed that this platform might not be ideal for the task. As a result, the concept of the BMR-620 shifted. Instead of using the BMR as its base, the project pivoted to the VEC, short for Vehículo de Exploración de Caballería, or Cavalry Reconnaissance Vehicle. The VEC is still in service today and is essentially a reconnaissance vehicle derived from the BMR platform, typically armed with an automatic cannon, although other variants were equipped with 90mm guns. A modified VEC chassis was indeed built specifically to mount the Meroka turret. However, the turret was never installed. The modified chassis and any existing photographic evidence of it was eventually lost. Why these projects were never completed remains unclear, but the most likely explanation is simple. The Meroka just wasn't as effective as an anti-aircraft system should be. While its shotgun-like approach made it excellent at saturating close-range targets, it had a very limited effective range of just about 1,500 meters. Given that we are now in the mid to late Cold War era, that was a serious problem. The BMR's intended targets were Soviet jets, capable of engaging from well beyond 2,000 meters and flying fast enough to exit the Meroka's engagement envelope in just seconds. In a naval CIWS role, this limited range wasn't as critical, but on land, as a ballistic anti-aircraft platform, it was considered a fatal flaw. This likely explains why the Meroka ATR also never went beyond the prototype stage. Today, the only known surviving piece of the BMR-620 project is the self-propelled Meroka turret itself, which can still be found at the Artillery Academy in Segovia, Spain. Later on, other Meroka-related vehicle concepts surfaced. One came from Chrysler Spain, who proposed an anti-aircraft vehicle based on the M41 Walker Bulldog light tank. The initial idea involved dual 20, 25, or 30mm cannons, but eventually evolved into a proposal featuring the Meroka turret mounted on an M41 chassis. The Army, however, showed little interest, and the project never advanced beyond a concept sketch. There's also the very curious case of the so-called Pizarro Meroka, a proposed concept combining the Meroka turret with the chassis of the Ascot Pizarro infantry fighting vehicle. This idea gained some attention, but it's still unclear whether it was ever a real project or just a sad result of a simple misunderstanding. In the end, the BMR-620 became just one of many ambitious military projects, unique in concept, eye-catching in design, but ultimately ineffective in practice. While it might have worked as a support vehicle, as an anti-aircraft platform, it was obsolete from the start due to its severely limited range. One could argue the issue might have been resolved with further research and development, but that step was never taken. Later on, the concept of an anti-air BMR would resurface when Spain offered Kenya a vehicle combining the BMR chassis with an Italian SIDAM 25 turret. Unfortunately, that idea never left the design specs either. If you're wondering how Spain eventually addressed its need for mobile air defense, there were other initiatives. One was the Rossio, a ballistic anti-aircraft system based on the French AMX-30 chassis armed with a 40mm Bofors cannon. But the true solution came in the form of the AMX-30RE, the Spanish-built version of the French AMX-30R introduced around 1990. Additional air defense capability was later provided by NASAM's batteries starting in 2004 and bringing an end to Spain's long-standing need for a dedicated ballistic anti-aircraft system. If you haven't done so already, we invite you to subscribe to stay updated on future content. If you'd like to contribute to the Fuel Fund, consider supporting us on Patreon or PayPal. We want to especially thank our medium and heavy tank Patreon supporters, Dan Fitzpatrick, Dave Shuford, Owen M., R. Rob, and Sopwith21. Your generous contributions help fund our research, illustrations, and video production. Until next time, keep us in your sights.